All right, wave properties. So continuing with our waves, now we're going to learn these properties or measurements of waves. So here are our property vocabulary terms and definitions. So the first one is frequency. Frequency is the measure of how many waves pass a point in a certain amount of time. So here's a diagram on the right-hand side. High frequency is the blue wave. As you can see, there are many waves happening in that same amount of time compared to the red wave. That is low frequency. There's only a few waves, maybe 3 waves that are occurring. The next property is amplitude. Amplitude is the measure of the distance between the line through the middle of the wave and a crest or trough. And remember, crest and trough are terms that we learned yesterday. So crest is that really high point of the wave, trough is that low point of the wave. So amplitude is essentially measuring the height of the wave. So if we look at our waves over here, it's the distance between the line through the middle of the wave. Well, the middle of the wave would be this line here and this line here. So our amplitude would actually be the measure from the crest to the middle of the wave, or the middle of the wave to the trough. And same for the diagram down here. So you would not measure the entire crest to trough. That is not amplitude. You are only measuring from crest to rest or trough to rest. Next is speed. So waves do have a certain measure of speed. So it's a measure of the distance a wave travels in a certain amount of time. So the equation is actually speed equals wavelength times frequency. What is wavelength? Well, wavelength is the measure of the distance from the crest of one wave to the crest of the very next wave. So as you can see, the wave on the left side has a very short wavelength. The measure of distance from this crest to this crest is very short. However, the wave on the right has a longer wavelength. Okay, let's practice identifying parts of a wave and properties of a wave. So I would like you to pause the screen, think about it for yourselves, and then we're going to go over it. Okay, so number 1, you should have gotten crest. Number 2, trough. Number 3, wavelength. Number 4, amplitude. And number 5, also amplitude. And remember, this is a transverse wave. Transverse waves have energy that is sent one way, and then the vibrations occur up and down, or perpendicular. So remember, this one moves perpendicular at right angles to the direction that the energy is moving. Okay, let's talk about frequency and energy. They do have a relationship. So the higher the frequency, that means that the closer the waves are together. So higher the frequency, this wave on bottom has a higher frequency. And as you can see, the waves are really close together. The crests are really close together. You could also measure the distance between trough to trough. That is also wavelength. So that's high frequency. The waves are really close together. And high frequency waves have high energy. So they have a lot of energy. So frequency and energy are directly correlated. That means that if you have high energy, you have high frequency. On the other hand, if you have low frequency, like this wave up here, this one has low energy. There's less waves here. This one has low frequency, low energy. Also, you've probably already noticed that frequency and wavelength are indirectly correlated. Indirectly. So what that means is, for a low frequency wave, you have these really long wavelengths. But for these high frequency waves here, you have these really short wavelengths. Next property to analyze is amplitude and energy. So the greater the force that you use to produce whatever wave that you're focusing on, the greater the amplitude that the wave is going to have. And the greater the amplitude, that means the greater the energy. So force, amplitude, and energy are all directly correlated. So what that means is, if you apply a lot of force, then you're going to have a really high amplitude. And if you apply a really high force to get a high amplitude, that means you have a lot of energy. So this low energy wave has a low amplitude. because remember, amplitude is the measure from rest to crest. So all of these distances here. This wave on the right-hand side has high energy. You can see that the waves have a much higher amplitude. And remember, amplitude is from rest to crest or rest to trough. Okay, I'm sure you all remember back to at least elementary school talking about pitch. If it's been that long, then we're going to review it real quick. But pitch is the highness or lowness of a sound perceived by humans. It's a qualitative observation, meaning humans can't really measure it without some sort of technology. Your really high-pitched sound may be a medium-pitched sound for me. But pitch is derived from frequency, meaning pitch is due to whatever the frequency of a wave is. Remember, frequency is the amount of waves passing by a certain point in a certain amount of time. And frequency is a measurable quantity. So it's a quantitative observation. You can measure frequency, and it's actually measured in hertz. It's measured in hertz, and you can also write it with just an H and a Z. So the higher the frequency of a wave, the higher the pitch. So a really high frequency wave would have waves very close together. That means that you would have a very high pitch. The waves shown at the picture, so an instrument is playing waves, they all travel at the same speed. So that means that the number of each wave will reach the ear in 1/100th of a second. So super fast traveling waves. The red wave, as you can see, has short wavelengths. So that means that the waves are close together and there's a lot of waves. So this is a high frequency, high sound, or high pitch. The instrument on bottom is playing a long wavelength. So as you can see, the waves, the trough to trough, or you could have done crest to crest, is much further spaced out, meaning there are fewer waves. This has low frequency, so it would have low sound or low pitch. All right, now let's look at amplitude again. So amplitude, remember, is the height of the wave, right? So if we were going to put our rest positions here, I know it's not perfect, but you get the idea. Remember, our amplitude is from rest to trough or rest to crest. Same for down on bottom. So amplitude is actually also the relative strength of the sound wave, or how much change in pressure occurs. So loudness and amplitude are tied hand in hand. Loudness is just the human perception of amplitude. So a high amplitude wave, like the one shown up here, has a very loud sound associated with it. On the bottom wave, the diagram on bottom has a low amplitude, so it would make a quiet sound. All right, so we've been talking about frequency, wavelength, and speed, and of course they're going to be related, and related they are with an equation. So remember, towards the beginning of the presentation, we said that speed is equal to wavelength times frequency. So if you know the wavelength and the frequency of a wave, you can definitely find the speed. But also, if you know the speed and the wavelength, you can find the frequency. So speed divided by wavelength would give you the frequency. And lastly, if you needed to find the wavelength, you would divide the speed by the frequency. So speed, as always, is measured in meters per second. Wavelength, because it is a unit of distance, is going to be measured in meters. And excuse me. And frequency, which is our new one, is measured in hertz. And hertz can be written as Hz. All right, fact or fake? Air represents empty space because it is invisible most of the time. All right, what'd you think? So, air is in fact a medium, meaning it's not empty space. It is a medium, just like water, with its own physical properties. So, for proof that you can see in your own home, have you ever noticed dust particles moving in a stream of light? So if you've ever looked through open blinds and the light is coming through and you can see the little dust particles in the air, that means that air is a medium. So the air is acting as a medium to hold those particles in the air. So air is not empty space. Empty space would be outer space or a vacuum in a laboratory? Okay, think about this one. Which travels faster, sound or light? So would a sound wave hit you first, or would light wave hit you first? Have you seen a distant action before you heard it, or do you hear it then see it? Well, each action is seen before the sound is heard, because light travels faster than sound. Kind of like the saying, he ran faster than the speed of light, because the speed of light is really, really fast. So an example, outside, it's thundering outside, and you go outside to look, you see the lightning, then you hear the thunder. And sometimes you don't even hear the thunder if the lightning's that far away, but you always see the lightning, so the light wave, and then you hear the thunder, so the sound wave. Okay, so with speed of waves, the speed of a wave through a substance is determined by the medium's or the substance's physical properties. So the speed of a wave depends on temperature. So how hot or cool is the solid, liquid, or gas? The medium, so can you compress it? Is it compressible? How dense is the medium? Is it a very dense liquid? Is it a not so dense liquid? Is it air that's dense? And so on. And then of course, speed obviously depends on wavelength and frequency, because we have our equation that says that speed is equal to wavelength times frequency. All right, that's it for now. Let me know if you have any questions. Thanks.